Hello students, in this section we solve another kind of problem that is called integer or integral based problem. Problem is cos n pi plus alpha equals to minus 1 to the power n alpha. We have to show it for any integer n. To solve this, we use following steps. Step 1. In this step, first we consider n be an even integer. That is, n equals to 2m, where m is any integer, Now, cos n pi plus alpha equals to cos 2m pi plus alpha. If we consider any value of m, suppose value of m is 1, then value of 2m pi is 2 pi plus alpha. That is, this one is pi, 2 pi and then alpha. That is in first quadrant. So, sign will be positive and multiplication of pi, any number we know, ratio remains unchanged. So, this gives cos alpha. If we consider another value of m, suppose 4, that is 2m pi is 8 pi. If the value of m is 4, then this is the value of 8 pi plus alpha. This one is as follows. This one is 2 pi. This one is 4 pi. This one is 6 pi. This one is 8 pi plus alpha. So, in all the cases, we see that the resultant value will give cos alpha. That is in first quadrant. Cos alpha, we indicate this by 1. Now, we consider another case, that is case 2. When n is an odd integer. In this case, we consider n equals to 2m plus 1, where m is any integer. And here cos n pi plus alpha gives cos 2m plus 1 pi plus alpha. If we consider value of m be 1, then resultant value will be 3 pi. Now we see here 3 pi, that is 2 pi plus pi, 3 pi plus alpha, that is in third quadrant, that is quadrant of tan. So, sine of cos is negative and multiplication of pi is if any number, then ratio remain unaltered, that is resultant will be minus cos alpha. So, we consider another value of m. Suppose m is 2 or m is 3, then this one is 7 pi. 7 pi means here 2 pi, 4 pi, 6 pi and then 7 pi and then plus alpha. Here also resultant lies on third quadrant, hence value will be minus cos alpha. This one is for third quadrant. We numbering this by equation 2. Now, if we see that in step 1, that is, here we already see that cos of nπ plus alpha equal to cos alpha, and in equation 2 we see that cos of nπ plus alpha equal to minus cos alpha. So, if we combine these two equations, thus we write from equation 1 and equation 2, we have cos of nπ plus alpha equals to minus 1 whole to the power n cos alpha for all integer n. For all integer n, thus in this equation we see that when n is odd, then value of cos nπ plus alpha is minus cos alpha when n is odd, and when n is even, then this equation gives plus cos alpha. So, for all integer n, we can say cos of nπ plus alpha equals to minus 1 whole to the power n cos alpha. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.